there are two categories of maximum power point tracking. The first one is indirect, and the second one is direct maximum power point tracking. Okay, this one is, of course, it's also called hill climbing. If you think of this as a hill, this is hill climbing. For the indirect, which is easier to implement but not as accurate, depending on the ambient condition, we can fix the voltage that comes out of the solar panel. So the first method, it's called fixed voltage. Last time we mentioned that in summer or in winter, we would have different illumination levels from the sun, so we would have different irradiances. So we can basically, based on the data that we have, we can come up with a fixed voltage to operate our solar cell at. So what do you think the benefit and the disadvantage of this method is? Well, the benefit is that very easy. It's very easy, of course, right? You don't have to have that much control, not that much measurement. So it's very easy to implement, but is it accurate? Do we have the same illumination level or irradiances every day in winter or every day in summer? Not really, right? So that this is not very common. It's because it's not very accurate. The other method that we have, it's called fractional. Do it with this one. Fractional open circuit voltage. So it's very similar to the first one. In short, it's also called FOCV, fractional open circuit voltage. So if you think about this open circuit voltage and this maximum power point, the maximum power point voltage, you can see that V of maximum power is always a fraction smaller than 1 of open circuit voltage. So and depending on the solar cell that you have, this value can vary somewhere between 70% up to 80%, means 0.7 up to 0.8. It might be slightly lower, slightly higher, depending on, like, if you're using monocrystalline or polycrystalline or different technologies, different semiconductors, so it can be different. So in the FOCV method, you basically measure the open circuit voltage, and then based on that you decide which voltage to operate your solar panel or solar cell or solar array at. This is slightly more accurate than this one because you have at least one sort of measurement, but again, it's not very accurate. The other problem is that you always have to measure the open circuit voltage. It means that, what do we mean by open circuit? It means that, let's say, like, you have a solar panel, solar cell, that it is supplying a load, and you want to make it open circuit, measure this, and then decide what voltage you have to operate at. Okay, so this is causes interruption to our load supply, right? So sometimes what they do in practice, if they want to implement FOCV, they would have, in a solar array or in a solar panel, they would have one pilot solar cell or one pilot solar panel that's only used for measurement. and then based on the measurement, measured open circuit voltage, they adjust the voltage of the voltage output of the solar cell, solar panel, to basically try to operate in the maximum power point. Okay, again, but not every solar cell or not every solar panel receives the same irradiation or illuminance, and based on that, this is not very accurate either. But it's very easy to implement again. So that was about the indirect or indirect methods. And the next one, the next category, is hill climbing algorithms. Okay, so there are two main kinds, right? One of them is called perturb and observe, or perturbation and observation, and the other one is called incremental conductance, or IC, incremental conductance. I'll talk about this one a little bit later. Let's first focus on P and O, perturbation and observation. So let's just like look at the PV curve here. Okay, so in the perturbation and observation, let's say that we are operating at this point, P1, V1. We have a perturbation to our system. It means that we change our voltage, our operating voltage. So we move it, let's say, to here. Or here. So you either move it this way or you move it this way. Okay, and we measure the power. Okay, so as you can see that we have to measure the power, so we have to measure V and I and multiply them to measure the power, or you have to have a power meter. And you can see that as you move V1 towards V2, P2 gets bigger than P1. And if we move V1 towards V3, P3 is smaller than P1. So based on this change of voltage and the measurement that we get from the power, we can basically guess or conclude where on this curve we are. Okay, so if it's here, and if we increase the voltage and it moves, the power increases, we know that it's basically on the left side. So over here, if I consider this one